What is up, guys? In this video I am going to be talking about something that was very confusing to me for a very long time as a chemical engineer, and that is Reynolds number. And Reynolds number is this thing that as an undergrad you're going to turn to the page in your textbook where they talk about it, and you're going to see something along the lines of blah blah blah, most important dimensionless number, and it is inertial to viscous forces. It is the ratio of some force. So we're talking about inertial forces and viscous forces, and while you've memorized this little canned sentence about what is Reynolds number, it really doesn't make much sense. And so the way I think about these things, and I was talking to a friend today at work that helped me fully understand what this topic is really telling you, is to think about some object traveling through a fluid. So, when we begin to study fluid mechanics, we think about things like little control volumes and how these control volumes are moving in fluids. And so if we were to take a control volume of fluid like this floss here and examine it as it is moving in a pipe, for instance, what's going to happen if we were to consider like the pipe walls to be this thing, the viscous forces would be the forces that are, hopefully you can hear it, it's like it's dragging against the walls. There's a little bit of friction. It can also be like turning like this, and so like that's losing energy. So there's like these viscous forces that are kind of pushing in the opposite direction of your fluid, even though it's moving this way. And then inertial forces are literally just the forces that are moving your fluid in the axial direction along certain cylindrical pipe in this case. So basically, when you think of Reynolds number, it's really good if you can just visualize this and think it is the ratio of your inertial forces, which is how hard does this thing want to move down my pipe that I have here, to the ratio of viscous forces, which is how much stuff is this thing doing and dragging along the pipe surface. And so that intuitively is what Reynolds number is telling you. And so the reason we care about that is, in the case where we have really high Reynolds numbers, what is that intuitively telling you? It's telling you that your inertial forces are dominant. That means that your fluid is moving so hard in that axial direction that it just doesn't really have time to really mess around too much with the dragging on the pipe walls or the tumbling or shearing against other fluids in that pipe. And so in those cases, that's where we see more kind of turbulent plug flow. So we've just basically got, if this was a pipe here, the fluid profile inside this pipe would be pretty linear, and it would just be moving as a whole plug, basically just a plug through this pipe. In the case where we have laminar flow, that's the case in which, these viscous forces are really dominant. So we're really seeing the effect of the shearing of the control volume against the sides of the walls of the tubes or other molecules or control volumes within this bolus of fluid. And that's when you'll see flow profiles that take on these parabolic velocity function. So like it'll be fastest in the center of the pipe and then slow down as we get out to the farther edges of the pipe, because that's where we're incurring the most amount of friction inside this thing. And so if you can understand this, you're going to go a long way. And when you're first introduced to this stuff in the textbooks, it really doesn't make much sense. So I hope this video helps. Let me know if you have any questions, and thank you for watching.